Good morning all, this is Rajakani doing PhD. Today we are going to see about the lesson light reflection and refraction. So first of all, get into the topic. We have to know about the some fundamentals, that is what is light, so how it works. So if you switch on the lamp inside your room, you can visible all the things around your room, right? So the light helps to see or visible to everything around us. So what is the main source of light? In our nature, sun is the main source of light. So from sunlight we can able to see the objects through around us, right? So how it forms? An object reflects the light that falls, and the reflected light receives to our eyes, it reaches to our eyes, so we can able to see the things to our nearby. So we are able to see the whether it is a transparent media or it is a opaque one. So sun is the primary source of our solar system and as well as our earth, and we can able to see the things in daylight. Sun is the main source, and its velocity, the light reaches to earth is 3 into 10 to the power 8 meter per second. The light is fall through an object, that time there is two phenomena can be occur. One is reflection, another one is transmission. So the reflection means when the light is fall through an object, it would be reflect, or it would be deviated through one various direction. And another one is transmission. If the object is fully transparent, that time the light will be transmitted. Okay, so not only these two phenomena, there are various natural phenomena can occur in nature, that are one is rainbow, and our camera working under the principles of same light phenomena, and our mirror is also one reflection one. So these are all the things we naturally see our day to day. We have a myth about the light traveling, that is light seems to be travel a straight line, but it is not a straight line. Why it is not? Because the light comes from sun, it was deviated in various direction. If we put a small source of light, and one shadow will be, one opaque object will be point out the object, that time only deviated its path and we can see the rays of light. So we only see the rays of light only, that is not at all a straight line. Next, another light phenomena is diffraction. The diffraction is how it forms an opaque object. If you consider an opaque object, like one box is kept nearby the light source, that time the light will be bended the edges of the corners of the box. So you see that the light is bending and it is not traveling along a straight path. So this bending is called a diffraction. So diffraction means the bending of beams. So this is the one of a fundamental phenomenon. History of dual nature. Light has two properties. One is wave property, another one is particle property. So how it forms in the beginning of 20th century, it becomes a wave theory of light. It has treated the interaction of light matters, like the stream of particle, how it became like a wave. So they get confused, and some earlier quantum theory will helpful to find out light is a particle nature and other as well as wave nature. So light has dual nature, one is particle nature, another one is wave nature. Come to our topic, what is reflection? So reflection means a polished surface like a mirror. If you fall the light, it will be reflect, right? So this is the reflection, and it has some laws you already learned in your earlier classes. First law is the angle of incident is equal to the angle of reflection. So angle of incident light is equal to the angle of reflection light, and the incident ray is the incident ray which was normal to the mirror at any point of incident. The reflection ray also lies in the same plane. So these laws you already learned from your earlier 9th standard classes. So I just brush up these things. So this is the thing also used in an spherical surface also. We consider a flat surface because mirror is a flat surface. Now we move to that spherical surface, it would be helpful. Next heading is properties of images. If you stand in front of a mirror, plain mirror, you can see yourself in a mirror, right? But it was virtual, and virtual means you can see only but you can't feel. So and the size of the image is equal to the yours, right? If you have a whole mirror and you see yourself full size of yours, then if you go far behind the mirror, that time the changes will occur, your size will be shrink. So this is the properties. And if the mirror would be curved, just imagine if the mirror would be curved, what happened? So let us explore. Spherical mirror, let us take on one spoon. You can easily see yourself in a spoon, right? So the spoon is one great example for spherical mirror because of its curved surface. So the definition of spherical mirror is the reflected surface of a mirror would be spherical in shape. So that is called the spherical mirrors. Spherical mirrors are classified into two types. One is concave mirror, another one is convex mirror. Let us take one simple experiment. From this, we come up with the conclusion what is concave and what is convex. So take one spoon, you can keep near your face, that time you can see yourself in a spoon. So a spoon has two sides, one is inner portion, curved surface, and another one is outer portion, that is bulked one. The inner portion is concave and the outer is convex. Okay, now start our experiment. First you take an concave portion, which means inner portion. You see yourself an inward version. If kept nearby your face, you can able to see the magnification version of yourself. Yeah, really it happens. So what happened really inside? Okay, let us explore. First, the concave mirrors are converging mirrors. What does means converging? It reflects the light on focus on one point. You also can change the position of an object. There will be changes of the 2 points. One is C, curvature center, another one is focal point. What is curvature center and focal point? We can learn it later. Okay, so then you can change the position. You see yourself as magnified version. Yes. So next thing is you turn the spoon. Now you turn the spoon, you can see the stringed version of yourself. Your minion is there. What happened inside? This is diverging lens. This is convex lens. Convex lens or diverging lens. When the light is falling to that mirror, it reflects various directions. So the focal point outside the curve, so you can see yourself as a minion or small one. Okay, this is the thing really happen in a convex and concave mirrors. So spoon is a great example to see that convex and concave mirror. From the spoon experiment, you can come up with this conclusion. When the reflector surface is curved inside and face towards the center of the sphere, that is concave mirror. And when the reflector surface is curved outside, so that is convex mirror. This is the definitions for convex and concave mirror. In spherical mirror, you have to learn some definitions about its parameters. First thing is, we are using to study about the spherical mirror. So the mirror is sphere, so it has center like that is C. The point C is the sphere center. From figure 1 you can able to see how the C is. Now our lenses are half sphere only. So the center is C. In second figure you can able to see that C. The C is center of curvature. So the center of curvature is the center of the spherical mirror. Now Another parameter is pole. So the pole is what's that? The center of reflected surface of the mirror. So it was lie on a mirror surface and it was represented as P symbol. Pole is P symbol. And another thing is radius of curvature. Radius of curvature is that distance between C and P. So C is the center of curvature and pole. The distance between pole and center of curvature is radius of curvature. So which was represented as R. And another important thing is principal axis. The principal axis is nothing but it is an imaginary line draw between that center of curvature and pole. So it was a straight line which goes from pole to center of curvature. So this is the principal axis. One more parameter is there, focus. So before that, we going to learn focus, we have to do one experiment, that is burning paper. You take one paper and one magnifying lens. So you kept near the magnifying lens nearby the paper in a daylight. So the sunlight was passed through that magnifying lens and it was focused through one paper. So in one spot, the spot of the light was concerned in one point. So that is called focus of concave lens. So it heat up the paper continuously for the sun concentration and the paper get burned easily. So this is that focus. So, and the position, the distance between that image and mirror, so that is called focal length. So the definition of focus is a number of rays parallel to the principal axis or fall on a concave mirror, observe the reflected rays. They are all meeting at a point on the principal axis of mirror. This point is called the principal focus of a concave mirror. In concave mirror, all the rays are come up and meet one point, that is called focus. What about the convex mirror? In convex, the reflected rays are appear and come from a point on a principal axis. The point is principal focus of a convex mirror. So the principle of focus is represented as F. The distance between pole and principal focus of the sphere is called focal length. Next important thing is aperture. So aperture is nothing but the diameter of the spherical sphere. You take one sphere, spherical sphere, the distance between M and N, that is called aperture. So the spherical mirror whose aperture is much smaller than that, its radius of curvature. The relationship between the radius of curvature R and focal length F of the sphere is R equal to 2F. When means the small aperture, the value of aperture is very small, that time only, and the principle of focus of a spherical mirror lies midway between the pole and the center of curvature. Next, we already learned about what is concave mirror and convex mirror and also its parameter. Now we move to that image formation by the spherical mirror. So image formation which was depending upon some certain positions, the position and also its size. So in concave mirror, it depends on three things. One is P, another one is F, another one is C. P is pole, F is focus and C is center of curvature. When the image is formed, it is real at some position and it founded to the virtual image in certain other position, and the image may be magnified or it would be reduced in size. It depends upon the position. So the position of the image is very important. In this tabulation, we learn about different position of an object with the image formation of concave mirror. So now we take a concave mirror. The position of an object will be at infinite distance. So infinite means it was limitless. We don't know where the object is. The position of image will be occur at the focus. It would be occur in a focus point, and
the size of the image is highly diminished. Diminished means it doesn't matter to us, like this, like that. Diminished means very very small. So the point size image will be occur in that, and the image is real, but it was inverted. So we already know that we using a concave mirror, we occur the image would be always invert. And another second, we positioned the object in an beyond C. C means center of curvature. So we put an object in an beyond C. That time the position of an image will be in between focus and C. So the image will be very diminished, like very very small, and also it was a real image and inverted image. So next one is we positioned our object at C. C is center of curvature. So we occur the image also at C. So it was same size and it is inverted image. So next one is in between C and F. So that time it reverse. The above things are occur in opposite side. So you can see that above 3 points. So like the same, it was reversed in a next 3 points. So in between C and F, we get beyond C. Beyond C means after that C. CC means center of curvature, and the size was enlarged. Enlarged means very very large, and the image was, nature of the image was as always real and invert. Okay, at point F we get the position of image at infinite. So it was highly enlarged, we can't able to minimize it. So but it was real image, but it inverted. And the between pole and F, we can positionate our object in between the pole and F. The image was beyond the mirror, so it was very very enlarged image, and also it is virtual, so we can't able to see it. Okay, so that's all from this tabulation. So from this tabulation we learn lot of things, how the image was changed with respect to the points of C, P, F, and also the infinite distance. So like the same, the convex mirror as well. So we can see the convex mirror later. Now we move to that another concept, that is representative of image formation by spherical mirror using ray diagram. So ray diagram, it's nothing but we already know that light was heated to an object, that is ray, right? Ray means it was fall to an object. So the light is one of a form of rays. So the ray diagram is nothing but we can represent a light rays with a straight line in paper. So we already use a curved surface. We put a curve in a lens or mirror. Like the same, we put a straight line for rays. Okay, so now we have a lot of cases. So first we go to that first case. So case number 1 is, now the ray was parallel to the principal axis. So the ray was travel along parallel to the principal axis. So the ray travels and hit to that surface. So we take two mirrors, one is convex mirror, another one is concave mirror. So first of all I take concave mirror. The ray was hit to that concave surface, and it will be reflect, right? So it refract. So incident ray was represented as I, and the reflected ray was represented as R. The reflected ray was travel to the focus. Here you see in figure A, it was travel through that focus. So this is first point. And another like the same, we take a convex mirror. That time the focus was beyond that lens or mirror. So if the light was travel along that parallel axis and it was hidden to the surface and it reflects, but it was diverged from the focus. So the difference is, first you take a concave mirror, it was travel through focus, but in convex mirror it was deviated. So this is the difference. So in case 2, the ray was passes through the focus. So here you see in figure A, the ray was in concave mirror, the ray was traveled through a focus. So now the incident ray was hidden through the surface of a concave mirror. It was reflect. So that time the reflected ray was travel along parallel like principal axis. So if we passes the ray through one focus, that time the ray was reflected like and parallel to the principal axis. Like the same in convex mirror as well. If we passes the ray towards focus, that time the reflection will be occur like the same as parallel axis of an.
The ray was passes through the center of curvature of a concave mirror. At that time you can see that the directed to the center of curvature of convex mirror as well. After the reflection, the ray was both reflected back at the same path. So if the light was passes along that in a center of curvature, that time the light rays was bounce back to the same path. So the last case is when the light ray incident ray was oblique to that principal axis towards the pole. It was directly towards the pole, and what happened, both mirrors, concave mirror and convex mirror, it reflects bounce back through the same angle, like incident angle, which also like the same as reflection angle. The image is also occurring the same, but it was in invert manner. Okay, this is the some cases of image formation with ray diagram.